Hey there, I'm Nick coming to you from the Technology Lab here at Kennametal in Latrobe, Pennsylvania. This is a place not many people get to see, and we're going to be showing you some pretty cool and high-tech stuff. I'm here with Jake, and he's going to be demonstrating some steel cutting with the brand new indexable milling cutter with tangentially mounted inserts that is known as the Milfor 12KT. With a depth of cut range of up to 12 millimeters, the versatile Milfor 12KT covers many shoulder milling applications, which we're about to show you.
With that, we're using a shell mill adapter with a KM4X63 connection running on this 25 horsepower machine.
We're going to start with a light cut on the periphery of this 3x6 inch steel block.
We're doing 2 passes with an 80 millimeter diameter cutter with 7 inserts. Each pass with the following cutting parameters: 3 millimeter axial depth of cut, 20 millimeter radial depth of cut, a feed rate of 0.25 millimeters per tooth, and 215 meters per minute cutting speed. Let's take a look at the surface finish we achieved with that 3 millimeter depth of cut.
We're seeing that with these cutting parameters, the spindle load is 42%. We should take a look at the metal removal rate that we achieved with this light cut. With a 3 millimeter depth of cut, 20 millimeter radial depth of cut, and 1,728 millimeters per minute feed rate, we achieved a metal removal of 104 cubic centimeters. Next, we're going to be doing a heavier cut on the periphery of this steel block with the Milfor 12KT.
This time, we're adjusting the cutting parameters to stay within the capabilities of the machine. We're increasing the axial depth of cut to 8 millimeters, while we are reducing the radial depth of cut from 20 millimeters to 15 millimeters. We're cutting the feed rate in half from 0.25 millimeters per tooth to 0.125 millimeters per tooth. The cutting speed remains the same with 215 meters per minute. We should now take account of the surface finish we achieved with that 8 millimeter depth of cut.
With these adjusted cutting parameters, we're seeing the spindle load decreased 37%. Let's compare the metal removal rate with what we saw in the first cut. With an 8 millimeter depth of cut, 15 millimeter radial depth of cut, and 958 millimeters per minute feed rate, we achieved a metal removal of 115 cubic centimeters. And finally, we're going to do the heaviest cut on the periphery of this steel block with the same Milfor 12KT cutter again.
We're doing 2 passes and adjusting the parameters again. We're increasing the axial depth of cut to the maximum of 12 millimeters, while we're decreasing the radial depth of cut to 10 millimeters. Feed and speed remain the same. Why don't we take another look at the surface finish again on the 12 millimeter cut.
And a quick check on the spindle load. We're at 46%. With the maximum depth of cut of 12 millimeters, 10 millimeter radial depth of cut, and 1,131 millimeters per minute feed rate, we achieved our highest metal removal rate of 136 cubic centimeters. Thanks for checking out the Milfor 12KT with me here in the Technology Lab at Kennametal.